let's try to solve some Leetcode problems. 1466. Reorder routes to make all paths lead to the city 0. Let me first explain the problem. So we are given an array of connections. So this connections is just one directionally connected. So for example, node 0 connected to node 1, it is like that. 0 to 1, and 1 to 3, and 2 to 3, and 4 to 0, and 4 to 5. So we are just giving this kind of a one directionally graph, but they are not all connected. What we need to return? Yeah, we need to return a path starting from 0. Yeah, but starting from 0, we are going to calculate if all the nodes can reach the city 0. So 0 is a city. We are going to calculate if all these nodes can reach 0. If it cannot, so we're gonna turn some of the directions. We're gonna reverse some of the directions. For example, 1 to 3, we're gonna reverse it to 3 to 1, and 0 to 1, we're gonna reverse it to 1 to 0. So, and 4 to 5, we're gonna reverse it to 5 to 4. So in this way, all the cities can reach to 0 to attend the meeting. So how can we solve this problem? Yeah, I mean, you need to think about it for a while about this problem. It must be very difficult. Yeah, because normally we are solving the directionally connected graph, but this graph is not connected. Or we are also solving the undirected graph. Yeah, but this graph is straight. Yeah, but we can turn this problem into a two directionally connected graph, and then we're gonna find which path we need to reverse. Yeah. So first of all, I'm gonna prepare an adjacency list to represent a undirected graph. So this undirected graph means all the nodes can be connected, but it is unconnected. So for each of the nodes, I'm gonna connect 0 to 1, 1 to 0. Yeah. Why should I do that? Yeah, because after doing that, it means all the cities can reach to 0. Yeah. But I need also to check which directions I need to reverse. So I also need a dictionary to check which path is truly directed and which path is falsely directed. Here, truly directed means 2 to 3. It is truly directed. But like 3 to 1, it is falsely directed because 3 to 1 actually it is not connected. I need to reverse, but I need to find it by using a dictionary. Now, let me try to solve it. As I explained earlier, I'm gonna prepare a adjacency list, and also I need to prepare a Boolean dictionary. So I'm gonna use the default dict with Boolean. Yeah, so here in this dictionary, I mainly store the key-value pairs. It is my key, and value is just true or false. I wanted to know if 2 to 3 is truly connected or falsely connected. Yeah. Now let me try to solve it. So for UV in connections, so for the graph, we're gonna GU dot append V and GV dot append U. So this is a undirected graph. All the nodes are connected. Yeah, we're gonna connect it because we're gonna use the BFS to traverse the graph. Now we're gonna prepare a tuple of which one is truly connected. So we can directly put the like EUV like 0, 1 here. Yeah, put the EUV inside the graph. Let me make a little bit of drawing about it. Yeah, so we can understand how it works. Yeah. So this is our graph. So after that, after I prepared everything, I'm gonna start from the source node 0 and to use the BFS to check one by one. So first of all, this 0 node will go to 1. Yeah. So first of all, this 0 node go to 1, but here it is false because 0 to because 0 to 1 is true. Here 0 to 1 is true. I put it inside a dictionary, so this gonna be true. So if it is true, it means I need to reverse. Every time while I find true inside the dictionary, I gonna reverse. So if it is true, I need a reverse. So this is one time. And then from 1 to 3, if 1 to 3 is connected, it is true. So I'm gonna reverse it the second time. And then 3 to 2. Because 3 to 2 is false, so I don't need to count it. Yeah. And similarly for here. So 0 to 4, it is false. I don't need to count it. But 4 to 5, it is true. I need to reverse it. So in total, I'm gonna reverse 3 times. I hope you understand the process. Yeah. So for UA, I'm gonna set a true because it is truly connected. If it is false, I don't need to do it. Yeah. Now I'm going to check the BFS. So for the Q, it should be the Q, and inside it would be a tuple starting from 0 node, and I also need a steps. It's gonna be 0. Yeah. So here would be the node and steps. I also need a visited set. So my visited set would be equal to a set, and inside I'm gonna have the starting node. It's gonna be 0. So I'm going to check the queue, and I will pop out the queue. It will be the node and steps would be equal to q.pop left. Yeah, I'm gonna pop it from the left side because it is a double-edged queue. So I'm going to check the neighbors because I'm going to traverse the graph. So for neighbor in G node, so I'm going to I'm going to put it inside the queue, right? So queue should let me first this is 4. So for neighbor inside the graph, I'm going to check if this neighbor is not in visited set. So this means I can put it inside the visited set. So I can add the neighbor, and the queue should append a tuple with neighbor and steps plus 1. Yep, not steps plus 1. Yeah, because I don't need to count the steps. So here, let me just delete the steps plus 1. I just need to put the neighbor inside. Yeah. Here also, I don't need the steps. I just need to put the neighbor inside because I just need to count the reverse, how many directions need to reverse. So I just put one node inside. I don't need to count the steps. Yeah. So, but if this neighbor is not inside the visited set, I would to put the neighbor inside the queue. But I also need to count how many edges need I to reverse. Here I prepare a result. So I need a check. So if this node and neighbor, so if node and neighbor inside the weighted set, it means it is true. So for example, 0 to 1, it is true. If it is true, my result should plus 1. And finally, I just need to return the result. So this is the entire code. Let me just run it to check. Invalid syntax. I think if neighbor not in visited set, if neighbor in visited set, there's no is. I think it is not. If neighbor default dict is undefined. Do you mean default dict? Yeah, it is a dict. There's some typo. And here should be not because I didn't use the step. Yeah. Now let me run it again. Something wrong with it. 3 times. Yeah, I put it inside. If let me try to use it this way. From the node to the neighbor. Yeah, let me try to use it like this way. If D with node and the neighbor would equal to true, so the result would +1. Yeah, let me write this way. If neighbor yeah, so here I think I need another if this is true. Yeah, so if this is true, so result should +1. I need to check it if it is inside of the dictionary. Yeah, normally I think it should also work if this tuple is inside of the dictionary. Yeah, I don't know why. Yeah, let me first submit it and to check if it works. As you can see, it works. So the basic idea is we're gonna use an undirected graph, and then we're gonna use the undirected graph traversal to find which edge need to reverse. Yeah, so here for this line, because I normally put the UV as a tuple inside of the dictionary, I think I can check it. Yeah, here I used a has set. Also yeah, here I used a dictionary. Also, I think if I use a set, it should also work. Yeah, let me just use it as a set. So if this node and neighbor in D, it means it is inside the dictionary, so the result would +1. Yeah, as you can see, it also works. Now it seems we don't need to prepare. As you can see, it is a little bit faster, but I don't know. Let's prepare to use another data structure. Let's just use a set. I think set would be much faster than dictionary. Now this is S, and here, because it is a set, so S dot add a tuple with UV. Now we just need to check if it is inside the set. It result would +1. Yeah, because if it is inside, it means 0 connected to 1. Actually, it needs to reverse. Yeah. Now let me submit it. Yeah, as you see, it also works. So no matter which kind of a hash table like set or dictionary we use, it is always works because the basic idea is the graph traversal for the BFS traversal. Thank you for watching. See you next time.